Hi everyone. This is a quick video about periodic behavior. We are going to start studying the trig function graphs. So we're going to start learning about periodic behavior, what those basic graphs look like, and then we'll go from there. So first thing is to identify what periodic behavior is. Periodic behavior means repetitive cycles. So take a second and think of some examples. And things you might come up with would be things like seasons, or you might think of the tides, or you might think of the number of daylight hours that increase through the summer and then decrease through the fall and winter. You might think about phases of the moon. Those are periodic examples of periodic behavior. So our trig functions model periodic data. And a periodic function is one which repeats itself over and over in a horizontal direction in intervals of the same length. And what's important is that you understand that the period of a periodic function is the length of one repetition or cycle. And you can say that f of x is a periodic function with a period of p if when you add the period to your input, so when I have x plus p, it just is the same as if I had f of x. So for all x's, and p is the smallest positive value for this to be true. Well, you guys know this because you've been looking at the unit circle, and I've been asking you to find places on the unit circle where the sine has the same value, or places on the unit circle where the cosine of theta has the same value. And what we did was we identified where those things were happening. So if we think about the sine of pi over 4, the sine of pi over 4 is here somewhere. That's our angle pi over 4. Or where else does the sine have the same value? Well, if we went all the way around by adding 2 pi, we end up at that same spot. And if we went all the way around again by adding another 2 pi, we end up at that same spot. And so here we figure out that the sine is a periodic function. So there are other kinds of periodic motion too, but we're mostly interested in waves. So what I'm showing you below, this is the graph of the sine. So this is y equals sine of x. And notice there's a few things about this that you need to understand. So the first thing is there is a max, and that max obviously repeats over and over. And when you think about a period, you are going from one spot to the next repeating value. So a period could be a max to a max, or it could be a min to a min, or it could be a middle full cycle to the next middle. There is also a distance to our central axis. So this here, let me go back, our axis, this is called the central axis. And the distance to that central axis is often labeled A, and that stands for amplitude. And you can find that by taking the difference of the max and the min and dividing it by 2. Because if we know what our maximum value is, and then I'll mark our mins, and we know what our minimum value is, then if we subtract those two, we would get the middle line, or we would get our amplitude. There's also then the period. So notice here, this is a graph of almost it's actually a graph of about a period and a half. So a period here, if we're starting at 0, we would go up, go back through 0, go down, and then end at 0. So this is the distance of one period. This is usually a length, even though it is often measured in radians or degrees. if you think about how the function works, remember that x is going to be your theta, so that's your radians or degrees, and y is going to be the value of your coordinate or your distance. All right? So here are some things about the wave that you need to know. I already said there's a central axis. Sometimes that's called a principal axis. If I could spell that right. Principal. And then the max and the min are equidistant from that. And when we divide it in half, when we take the distance and divide it in half, then we get the amplitude. All right? So those are some key features about our graph so far. You can go ahead and pause this video or stop this video and finish the problems on page 2.